Hi, I'm Ryan, and today I'm going to explain to you how to find the nth term of a sequence. And those sequences would be arithmetic and geometric sequences. Some vocabulary terms you might need to know are geometric sequence, which is a sequence in which the ratio of any term to the previous term is constant. Arithmetic sequence, a sequence in which the difference of consecutive terms is constant. A common ratio, which goes with geometric sequences, which is the constant ratio from any term to the previous term. A common difference, which goes with arithmetic sequences, is the constant difference between terms. An arithmetic series is the expression formed by adding the terms of an arithmetic sequence. And a geometric series is the expression formed by adding the terms of a geometric sequence. And I found a little cool comic which represents an arithmetic sequence. And some ways to help you remember is that when you see the words ratio, multiply, or divide, those usually go with a geometric sequence. And when you see the words difference, add, or subtract, those usually go with an arithmetic sequence. And the formulas for these equations are given to you on the SOL formula sheet, so you don't need to worry about remembering them. And here are the two formulas for geometric sequences and the two formulas for finding the terms in arithmetic sequences. And now for our first problem. What is the seventh term of the geometric sequence with a first term of 729 and a common ratio of 1/3? And there's the formula that I used. And AN would be equal to 7, because that's the number of the term you're trying to find. A1 would be 729, because that's the first term in your sequence. And the ratio is 1/3, and that was also given to you. So you would plug those into the formula. You get A7 equals 729 times 1/3 to the 7 minus 1. So you simplify that and you get A7 equals 729 times 1/3 to the 6th power, which 1/3 to the 6th power is equal to 1 over 729. So when you multiply those together, you get A7 equals 1, with the 7th term equals 1. Now for the second problem, the real-world application problem. John received $1 on his first birthday from his grandparents, who agreed to double the amount with each consecutive birthday. If his grandparents hold up to their agreement, what amount will John receive on his 20th birthday? Since you're trying to find what he receives on the 20th birthday, the term you're trying to find would be 20, so AN equals 20. Your first term would be 1, so A1 equals 1. And your ratio is 2 since he's doubling it every year. So you plug it into your formula, and A20 equals 1 times 2 to the 20 minus 1 power. You simplify that, and you get A20 equals 1 to the 2 minus 19 power. Then you simplify 2 to the 19th power, and you get 524,288. And then you would multiply that by 1, and you get the 20th term equals $524,288 for his 20th birthday. And for the third